Hi students, good morning. In the last class, what we completed? Modulus function and some problems also we completed. We didn't start Signum function, no? Next one is Signum function. Signum function is denoted by like this: Sgn of x, signum of x, Sgn of x, and defined as mod x by x for x not equal to 0, 0 for x equal to 0. This is the Signum function definition. Sgn of x equal to mod x by x. But we know that from the modulus function, what we know that mod x equal to x for x greater than or equal to 0. Equal to 0 means 0 you will get what it means. So x less than 0, what you will get? Minus x you will get. Okay. Similarly, we can write like this also: modulus of x minus 1 equal to minus of x minus 1, negative when this x minus 1 less than 0, okay, and x minus 1 whenever x minus 1 greater than 0 or equal to 0 means if you like this you can take x minus 1 less than 0, nothing but x is less than 1. Here x is greater than or equal to 1. Means graph if you draw, where you will get? This is 1, less than 1 minus, greater than 1, greater than or equal to 1 plus, means graph is like this you will get. This is mod x, this is mod x minus 1, this is mod x, this is mod x plus 1, here x minus 2, x minus 3, here x plus 1, x plus 2, like that. Okay. So mod x condition is this one. By that one, modulus of, suppose if you take here minus, when you can take here minus? When x less than 0, right? When we can take here plus? When greater than 0. When already equal to 0, it is 0 given now. Okay. Also you can write it as get cancel minus 1, x less than 0. Also you can write here x equal to 1 whenever x greater than 0, 0 whenever x equal to 0. This is exact our Signum function. Means for the positive values you take 1, for the negative values you take minus 1, for 0 that one. What is saying? For all the positive values you take y value is 1, y only, no, this one you can take y equal to or f of x equal to. For all the positive values you take 1, for all the negative values you take minus 1, for whenever 0 you take 0. These values if you take on x axis, y axis, one graph what you will get? 0, 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3, and these are minus 1, minus 2, minus 3, right? Okay, now x equal to 0 I will take. What about the y value? 0 only, no? That is 1 point. X equal to 0, origin. X greater than 0 means what is the meaning? 0 point onwards. X values are what? 0 point. Means not x equal to 0. 0 point means just right neighborhood of 0. Whenever you are moving just right side of 0, y value is what? 1. Y value is 1. Means if you take 0.1, y value is 1. So here what we have to take? Open circle we have to take. Why you are taking open circle? At x equal to 0, y value is not 0, not 1, that is 0 only. But whenever x 0 point onwards, y value is 1. Means y value 1 where it is started? After the 0. After the 0. So that's why here open circle, all these values. X equal to 1, y value 1. X equal to 2, y value 1. X equal to 3, y value 1. Right? Nothing but whenever x equal to 0, y equal to 0. Whenever x greater than 0, y equal to 1. Whenever x less than 0, y equal to minus 1. So greater than 0, y 1. This is y equal to 1 only, no? Next. Whenever x less than 0, y value what? Minus 1. Means these values. So this is y equal to minus 1, this is y equal to 1, this is 0. This is our graph. Graph of Signum function. See, x0, 0. X greater than 0, y is 1. X less than 0, y is minus 1. Here you will get. Okay, no? Right. Now what about the domain? What about the domain of this function? Means x values from where you are taking? All the real numbers we can take, no, because greater than 0 values are there, 0 value is there, and less than 0 values also there. For these three conditions, y value existing also. So that's why real number. What about the range? Means whatever the real numbers you take, y values exist where to where? Plus infinity to minus infinity. Is there here values? No. Here is there values? Is there here values? No. Here also not there. Only 3 values only getting. Any real number you take, only 3 points. What are they? 3 values. 0, minus 1 and 1 only. So that's why what we have to take range is, this is the set form. Minus 1, 0, 1. Only 3 independent values. Right? Suppose x equal to 1.5. Y value? 1. X equal to 10. X equal to minus 1. Minus 1 only. X equal to minus 10. Minus 1. X equal to 0. 0 like that. So this is the graph. This is y. Whenever positive value is y equal to 1, negative value is y equal to minus 1, 0, 0. Right? This is about the Signum function. In general, okay, this is for only x only. But in general, in place of x, suppose x square plus 1 log x, like that different functions also I will give. Suppose at that time what we have to do? Means generalization, if you do like this you will get. Listen, suppose same signum of f of x is there, whatever the function in place of, here previous one is x only. So how to take? Nothing but modulus of this one, modulus of f of x divided by same function. Whenever modulus this f of x not equal to 0, 0 whenever f of x equal to 0 you take it. Okay, and now that is equal to, can you write, suppose this is mod x is f of x is less than 0, this f of x is less than 0, here what will get? Minus 1 you will get now, because this is minus of f of x by f of x, get cancelled. Whenever f of x greater than 0, what you will get? 1 you will get. Whenever f of x equal to 0, what you will get? 0, that's it. What is there? Okay, no? In place of f of x, what you got here? F of x, that's it. But graph is, because whatever the values of this one, here minus 1, 0 and 1 is there, but according to these values, Understood or not? Y values are same. This is the same, according to this one we have to take. But what are the x values means based on this one exist. Okay, no? Right. Right. This is a very small function. This is a Signum function. So actually problems also there, but I am not going to problems. Only just what, how to take that function, what is the definition, and how to apply on some problems only. Properties we are not taking, right? Because that is one of the topic is there, functions chapter, there we have to discuss actually. Next, greatest integer function. All these functions are how many times you are going to use, not only first PU, second PU, in your engineering also you are going to realize later. Greatest integer function. Also called as step function. Also called as floor function. Step function, this is also one of the most important function in our functions chapter. Greatest, why it is called as greatest integer, why it is called as step function, why it is called as floor function, I will explain whatever it may be. But generally I will explain first about the greatest integer function, after that the definition we will take. Okay. See, one real number I am taking. Can you write any real number or otherwise 3.2? This is a real number, no? Every real number can be written as one integral part and one fractional part. Can you write? So this is a real number if you take, this is integral part. This is integral part and this is fractional part. But here what they are asking, greatest integer of that function asking, means how to find that one. Okay, suppose 5.06, what is the integral part? 5. What is the fractional part? 0.06 is the fractional part, means every, suppose 2, it is a real number. This, what is the integral part? 2. What is the fractional part? 0. Right? Now, here now I am asking to you, for which real number you will get integral part is 8. For which real number you will get integral part is 8. Means here see, this is a any real number, you can write some what integral part and fractional part. It here also integral part and fractional part. But here what I am asking, for which real number you will get integral part what 8. Integral part 8 only I want. 8 in that integral part is 8 only, no? General meaning concept I am teaching, very easy concept only. If you follow very easily you can identify. Right. Okay, one point is there. Like this is there. It is the one real number. In that integral part 8. 8.6. Integral part 8 only, no? Etc. 8.999, like that is there. Integral part 8 only, no? Okay, one more example. For which real number integral part is 10. 10.0. next to 10.000256, 10 only, etc. 10.9, 10 only. Means by these two examples, what we are observing, for integral part of 8, that real number should be lies between closed interval. That's why first I completed the intervals. Closed interval 8 to open interval 9. In this one, any real number you take, for that real number, integral part is 8 or not. Okay. Next, for this real number, here for these examples, 10, 11 or not. Here closed, here open. Why you taken here closed, here open? Because closed means we can take that one, integral part is that only. But right side we can't take 11 because up to 10.999, because it is not only integers, here in real numbers, like that. Means by this one you can define greatest integer function. What is that means? X is real number. One value x I am taking. From where I am taking? Real number. N is, here see, in these, this one is, these two should be integers only or not? Means by these two, can you take one example, close interval n and n plus 1, where n belongs to integer or not? Right? Can you write this is 10.2? We can't write it, 10 only. These two integers only or not? 10, 11, both are integers only. Means by this one you can generalize the formula or not? Here closed, here open. So if any integer satisfying this condition, definitely integral part of that one is n only or not. Means x, one real number from means x is one real number, n is one integer, and these two satisfying this condition, n less than or equal to x less than n plus 1. Can you write this closed interval as equal, open interval as less than? Next, then the greatest integer function is denoted by like this, closed x, step x, it is denoted by like this. It is equal to what? N. Greatest in this one, what is the greatest integer? N only or not? In this one, what is the greatest integer? Integer is what in this one? Integral part is what? 10. In this one, integral part is it satisfying this condition? Here 8 less than or equal to x less than 8 plus 1, 9. 10 less than or equal to x less than 10 plus 1. What is the integral part? This one only or not? Okay, you definition you leave this one. This is the definition. But why it is called as greatest integer function? Still not completed explanation, just one basic information I given. And now, because here that condition you got now, so that's why I given definition also. Okay. And now come to this one. See, 0, here 1, 2, 3, 4, 5, 6, 7 and 8. One real number I am taking between 5.5 means between 5 and 6, right? In that 5.5, what is the greatest integer? So always greatest integer function is denoted by like this symbol. So 5.5. What is the integer? Means this is like this they given, means in this one what is the integral part? That one asking. What is the integral part? 5. We know that. Means 5, 5.1, 5.2, 5.3, 5.4, etc. 5.9. Anyone you take, integral part is 5 only. But why it is called as greatest integer function? 5.5 is there, no? Integral part is 5, right? We are saying, because why it is called as greatest integer means left side of this real number, you observe all the integers. All the integers, you observe all the integers. Among all these, which one is the greatest one? 5. That only our answer getting or not? Right? Now what is the greatest integer of 4.9? 4. Okay, you take a number, a real number line. Here anywhere 4.9 you will get, no? Right? Among, means left side of this 4.9, observe all the integers. Which one is the greatest one? 4. So that's why 4. Means any real number they given, greatest integer of that real number they asking, means left side of that real number we have to observe how many integers will be there. Infinitely many will be there. So in that infinitely many, which one we have to choose? Greatest one. That is called what? Greatest integer function. Suppose 2.5. Tell me. 2.1. Here anywhere 2.1 is there. Left side of this one, how many greatest integers are there? Infinitely many integers are there. All these are infinitely many. But in that one, greatest one is what? 2. So that's why this answer is 2. Like that they ask. Okay. These are the positive values. Okay. Suppose minus 2.8. Exactly minus 2.5 you take. Okay. Where it is located? 1, minus 1, minus 2, minus 3, minus 4, minus 5, etc. Okay. Here also many are there. Here anywhere minus 2.5, right? Now minus 2.5, if you take minus 2, wrong answer according to this one. Here what you are taking? 5.5, 5, 4.9, 4, 2.1, 2, minus 2.5, minus 2, wrong answer or not? Because what they asking? Greatest integer of that real number, left side of that one. What is the left side of this one? Greatest integer is minus 3, no? So that's why what you will get? Minus 3, because simple meaning. This value is between 5 and 6. 5 answer. Left side. This value is between 4.9. 4 and 5. 4 and 5. What is the answer? 4. Left side. This value is between 2 and 3. What is the greatest integer of that one? 2. This is in between minus 3, minus 2. What is the answer? Minus 3. Now greatest integer of minus 11.6. It is in between minus 12, minus 11. So that's why what is the answer? Minus 12 you have to take. What we have to take? Minus 12. Because greatest integer left side of that one. Left side of minus means it is in between minus 12 and minus 11. Left side of that real number greatest integer is what? Minus 12 only. That one we have to take. Understood now why it is called as greatest integer function? Right. Now greatest integer function of or greatest integer of any real number, it is denoted by what step x? Is it always less than or equal to x? Right, because 5, 5.1, 5.2, 5.3 etc. you take. This is integer, because here output what you will get? Any real number you substitute inside, output what you will get? Integer only or not? Because here 5.5 you substitute. What is the integer of that one? 5. 5.1, 5, 5.2, 5, 5.9, 5.0001, 5 means output is integer only getting or not. Now if you take 5, greatest integer of 5, 5, it is not less than but equal to x or not, right? 5.1, 5, 5 less than or equal to 5.1 or not? 5.5, 5, 5 less than or equal to 5.5 or not? Satisfied? Like this we have to take. Means greatest integer function less than or equal to given real number. Right? Right. Means now greatest integer of any integer, output what you will get? Integer only you will get, no? integer of 2, 2 only. In that integer is 2 only you will get. Next 3, 3, 4, 4 like that only. Means greatest integer of any integer is integer only. Now greatest integer of 0.1, 0, because it is in between 0 and 1, 0 and 1, right? 0.1, left side of that one, what is there? Integer 0, that only greatest, no, like step of 1.5, 1, step of 2.0, 2 only, step of minus 2.0, minus 2, because the reason minus 2.0 nothing but minus 2 only, integer nothing but what? Integer only or not, but minus 2.1, this is in between minus 3 and minus 2, careful about that one, okay, no? Right, clear? Also you can take, also by the condition, see what you taken, if you take any real number, x belongs to real number, n belongs to integer, and such that n less than or equal to x less than n plus 1 means greatest integer function is what? N only. I will define like this also. See, one value 0 less than or equal to x less than 1. Is it satisfying this condition? What is the condition of this one? Here n is there means here n plus 1 is there. Here equal not there. Here 0 is there means here 1. 0 plus 1, 1 only or not. Now in between 0 to 1, how many real numbers are there? Infinitely many. Means 0 you can take. Which value is satisfying this condition? 0 less than or equal to x less than or equal to 1. What we can take? 0, 0.1, 0.2, etc. 0.9 or not. These are not integers. In this one, what is the integer? This one only. Itself is the greatest. Then greatest I will take. Equal to what you will get? So step of x, what you will get? 0. Whenever that x value and n value satisfy this condition, then step x equal to what we take? N. Here in place of n, what is there? 0. So that's why it is what? 0. 1 less than or equal to x less than 2 or not. Can you take? Is it satisfying this condition? Like this also you can take. Now what is the step x value? 1 or not. Next 2 less than or equal to x less than 3 means any value between 2 and 3 including 2, step x equal to 2 only you can take or not. So what is the step x value? 2, because greatest integer of 2 is 2 only, between 2 and 3 also 2 only, like that. Suppose 10 less than or equal to x less than 11, what is the greatest integer function of this one? 10. Suppose minus 1 less than or equal to x less than, right side what should be there? Tell me. 0. Add plus 1, what you will get? That one right side. Now what is the greatest integer of this one? Minus 1, because step of minus 1 is minus 1 only. Minus 1 to 0, minus 1 only. Next minus 11 less than x less than or equal to x less than, right side should be what? Add plus 1, minus 10, because it is in between minus 10 and 11, means step of minus 11 is 11 only, and suppose minus 11 to minus 10, so greatest integer of this one is what? Minus 11. Okay. Now you have to learn the subject, means all these you have to definitely have to learn. A plus b whole square type they won't ask, you forget it, you leave that one. Okay, now you have to learn new things, because new things only will come in examination. They always you have to ready to learn. Now 0, 1, 2, 3 x axis, -2 -3. Now up to now what you learn? Greatest integer of any integer is integer only. Suppose the value is in between 0 and 1, means 0.1 greatest integer 0, 0.2 0, 0.3 0, means greatest integer of 0 0, 0.1 0.9 0 only, means y equal to step x I will take. I am drawing the graph of this one. In this one I am taking some values between 0 to 1 and including 0. Y value what will get? Y value is 0 only you will get or not? The value between 0 and 1 including 0, y value also 0 only, no. So y value is 0 and means lies on x axis only, no. So x value is 0. What is the step x? 0. 0.1 0.9 0, means year to year. But whenever x value is 1, step x value means whenever x values it starts from 1 and end with 2, means less than 2. Y value is 1 only or not? Y equal to step of x equal to 1 only you will get, no, means the value is step x means 1, y value is 1, here you will get. So here open circle you have to take or not, because whenever x equal to 1, y value is not 0, y value is 1, y value is 1. Now step of 1.1 1, 1.2 1.3 1.9 up to 1.9 1 only or not, means year to year 1 only you will get, okay. But whenever x equal to 2, step x value is 2, means here you won't get, whenever x equal to 2, here you won't get point or not, where you will get? It jump to 3, sorry, jump to 2 here. Next 2.1 2, 2.3 2.9 2 only. But whenever x equal to 3, y value not 2, it jump to what? 3. 3.1 3.9 3 like this. So here also the value is between -1 to 0, means what you will get? Like this you will get -1 only. The values between these two, what you will get? -2 you will get. Means what you are observing, some steps getting or not. So that's why it is step function. Otherwise if you treat first floor, second floor, third floor, it is also called as floor value function. Means nothing but the value is 0 including 0 and 0 and 1. What is the step x? 0. 1 including 1 and 1 and 2, 1, 2, 2 and 3, 2, 3, 3 and 4, means between 3 and 4, 3, -1 to 0, -2 to -1, -3 to -2, -3, right? Now one second listen. Step of -100.1, -101, because left side one extra you have to take. It is in between because -101 to -100. Here only confusion is there. Remaining okay. Don't confuse there. -0.6, -1 because it is in between -1 to 0. Next -1.9 -2, right? Next 5.6, 5, step of 5, 5. Next step of 10.9, 10, like this you have to do, okay, no? So this is the, now what is the domain and range? Domain you taken or not? All the real numbers you can take, any real number. So if you substitute y value also getting or not? In place of x, any real number you can substitute. So real number. But output what you are getting, tell me anybody? Any real number you substitute, but output is integers only getting or not? Because that only meaning is there. So that's why integers only. Range is what? Integers only. Because between these two, is there any y value? No. Here only y value is there. Here y value means y value is 0. Here y value 1. Here y value, is there any curve between these two? Y value between is there? No. Means all the integers only getting or not? This step integer, that step integer, 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 but between not there. We are jumping. We are not taking the real numbers. Okay, a very good concept is there. Properties are the more, means very interested properties are there based on this one. But till now you learn that how to take the values of the greatest integer, what is the meaning that one, and what is the graph, what is the domain and range. Okay, no? Not only one or two times you have to practice, then you have to take the grip. Then you can do the problems based on this one. Okay, no? Now problems also I am not giving, but information given, what is the greatest integer function, right? Okay. Right. Next, fractional part function. Integer part you take, and fractional part also you have to take or not? Right? Fractional part, here also same. Every real number can be written as one integral part, right? One fractional part. Fractional part is denoted by like this. Integral part is already we have seen. This is fractional part. Every real number can be written as one integral part, fractional part. So if x belongs to real number, the function which is in the form of x minus step x is called fractional part function. Fractional part function. That only know, if you bring this one this side, here fractional part equal to this one this side, what you will get? X minus step x, means from the real number integer you remove, what you will get? Fractional part only you will get or not, that only. So it is denoted by what? This one. It is denoted by this symbol. Okay. Suppose 5.06 you take it. What is the fractional part of this one? 0.06. Next to 2.51 you taken. 0.51 means, suppose like this they given, means what they asking? Fractional part asking. Just what we had to write? 0.06 we had to write. Suppose this one they given, what they asking? Meaning is in that what is the fractional part asking. Suppose now only we see in 2.51 asking, this one means what they asking? Integral part asking. What we have to take? 2 we have to take. Okay, no? Right. Now see, minus 2.6, what is the fractional part? Integral fractional part, is there anywhere negative? Negative not there. Answer, tell me anybody. Can you write this is minus 3 plus 0.4 minus 3 is 0.4, how much? Minus 2.6 only or not? Clear? And now what is the fractional part? Now you converted into positive integral fractional part like this. Now clear? Simple thing, right? Minus 3 plus 0.6, how much? Minus 2.6 only, no? So now you have to take, now you convert it into positive, so 0.4 is our fractional part, okay, no? Now by using this information we have to take the graph, means fractional part range, anybody tell me? Fractional part range. Domain is real number, all the real numbers you can take, because already now you defined it, this is x belongs to real number. What is the range? Any means real number, in that fractional part is 0 is there, some means real numbers for every integer. What is the fractional part? 0, 0 or not, 0.1 will be there, 0.2 will be there, but 1 we can't take, means closed interval 0 to open interval 1. This is the range or not? Because any real number you take, suppose 5 is there, what is the fractional part in this one? 0. 5.2 is there, what is the fractional part? 0.2. 5.5 is there, what is the 5.9 is there, what is the fractional part? Now 6 is there, again it starts from 0, correct or not? Right. Okay. Graph. Fractional part not equal to 1, close interval 0 to open interval 1 up to 0.99999. And now here 0 is there, here 1, here 2, 3, minus 1, minus 2, minus 3, 1, 2, 3, minus 1, minus 2, minus 3. Okay. Now I am taking the graph of fractional part, y equal to fractional part, means in place of this one any real number if you substitute, output what you will get, that one we are identifying. Okay, now that real numbers first I am taking between 0 to 1. So y equal to, suppose if you take here 0, what you will get? 0. 0.1, what is the fractional part of 0.1? 0.1 only, no? What is the fractional part of 0.9? 0.9, means what you are doing, fractional part of 0, 0 only, fractional part of 0.1, 0.1, fractional part of 0.5, 0.5, 0.9, 0.9, 1, fractional part of 1, again it is come down to what? 0, means up to here it is moving, but whenever you are taking 1, it is comes down to what? Again 0, fall, means 1.1, fractional part of 1.1, 0.1, up to 1.9, fractional part of 1.9, means 1.1, 1 means 0.1, 1.5, next here I will take, means like this, getting now. Now 1.5, 0.5, 1.9, 0.9 up to here, but again if you take 2, it fell down to what? Means here not there point. Is there here? 1 you won't get. Next 2.1, 2.5, 2.9, 0.9. But if you take 3, again it comes down to 0. If you take 4 like this, okay na? Now here also same thing, like this, right? Clear? So this is about the fractional part. Means graph is 0 is there, but 1 not there. Between close interval 0 to open interval 1 only. Means what is the domain? Domain equal to what? Any real numbers, because any real number you take on x-axis, any real number you take, y value exists or not, fractional part, either 0 or 0.1 or 0.9, any one you will get. But what about the range? Any real number you substitute, but that is not exceed what? Means this interval, close interval 0 to 1, open interval 1, right? Because 0 may be 0.1 but not 1, right? So that's why this is closed interval 0 to open interval 1. So this is about the fractional part 1, fractional part function, okay now? So always fractional part of x means x minus step x. X minus step x nothing but what? Fractional part of function. This is integral part, this is fractional part. Understood or not? So this is about the today 3 functions we discussed now. What are they? Signum function. For x greater than 0, 1, x less than 0, minus 1, x equal to 0, 0 getting. Next, greatest integer function. Why it is called as greatest integer function and step function and what? Floor function. What is the domain and what is the range? What about the graph? This one also we discussed. Second one, fractional part function. This is about the fractional part function. Okay, now 2 more are there. 2 more also we will use sometime, means many times we will use frequently we will use, that one only I am discussing. That is exponential function and logarithmic function. Logarithms properties we discussed. At that time I told in the functions chapter we will discuss about the graph. So graph and domain and range, how to take that one. Okay, now exponential function and logarithmic function. After that I will start remaining topics, what are they, right? Our original topic or what we have to decide that.